How to control fermentation temperature. Ideally, the brewing process should be closely regulated within a narrow temperature margin to achieve optimal results. Failing to take adequate steps to properly regulate the thermal aspect of beer production is a costly mistake many new brewers make, which can result in unsatisfactory products. 1. What temperature is ideal for brewing beer? The ideal beer fermentation temperature depends on the type of beer the brewer is trying to produce. Broadly speaking, satisfactory beer brewing temperature is between the range of 40 to 70 degrees F. Lager fermentation temp, beer fermentation temperatures ranging from 45 to 55 degrees Fahrenheit are adequate to achieve the brewing yeast temperature for a high-quality lager. Ale fermentation temp, the ideal brewing fermentation temperature for ale is from 68 to 72 degrees F. IPA fermentation temp, temperatures in the mid-60s degree F range can satisfactorily ferment an IPA. Stout fermentation temperature, the average thermal conditions for brewing high-quality stout varies between 64 to 67 degrees F. Pilsner fermentation temperature charts categorize Pilsners as best fermented at 50 to 55 degrees F. Bock fermentation temperature, to ferment great Bock, the temperature should be regulated between 50 to 52 degrees F. 2. How do breweries control fermentation temperature? Apart from selecting an ideal yeast strain, choosing and maintaining an optimal brewing temperature is vital for achieving the desired beer quality. A brewery chiller unit is ideal for large-scale production. Most brewery chillers utilize a solution of glycol and water as a coolant, though other refrigerants are available, used to keep the chiller pump running smoothly. 3. How does a brewery chiller function? A beer chiller unit is composed of a refrigeration unit, interconnected tubing, and an automatic thermoregulator. The cooling fluid is chilled in a refrigeration tank before being pumped through heat exchanger tubing that surrounds the fermentation vessel. The heat from the brewing vessel is transferred to the circulating chiller fluid, which is subsequently pumped back to the refrigeration component for recooling. The overall effect of this heat exchange cycle is a reduction in the fermentation temperature within the brewery vessel. How does a brewery chiller regulate the fermentation temperature? Although utilizing chilled glycol as a coolant is quite advantageous, if left unregulated, it can excessively cool the brewing process. To avoid brewing beer with poor quality, it's essential to keep the temperature within the fermentation vessel constant. This can be achieved with an automatic temperature controller. A temperature-controlled solenoid valve is connected to the tubing leading to the heat exchanger. Additionally, a temperature probe is installed in the beer fermentation vessel through a thermal well, which automatically detects thermal changes within the brew. The valve mechanism will automatically open or shut off in response to the temperature within the fermentation vat, therefore restoring it to a predetermined value.